Okay, we're looking at the first year core textbook, mixed exercise 8, and we're on question 8. Okay, so to start with, I'm just asked to do an binomial expansion, and I'm basically asked to expand the whole thing. So you do get the binomial formula, so you get that on the formula sheet in the exam. Let's get my screen up. Okay, so I'm doing, so part A, I'm doing 3 plus 2x to the power of 4. Okay, so for us, A is 3, B is 2x, and N is 4. So the first term is 3 to the power of 4. Then from 4, choose 1. So the power of 3 is going to decrease, and I'm going to have just one lot of 2x to the power of 1. So that's the term there I've just done. So then it's 4, choose 2. The power of 3 is going to decrease, and the power of 2x is going to increase to squared. 4, choose 3. The power of 3 is going to decrease. I'm going to put a power of 1, even though obviously that is just 3. And power of 2x is going to increase. And then 4, choose 4. Again, I'll write 3 to the 0, just so we can see that pattern. So what should happen on every term, the powers should add up to the power there. So 4, so 1 and 3, 0 and 4, 2 and 2, etc. And then as we're doing the full expansion, my very last binomial coefficient is part of it is 4, choose 4, and obviously that has to be the end. 4, choose 5, you try it, it'll say maths error. That just doesn't exist. And 4, choose 4 is just 1. So there is actually, 4, choose 0 for your first term that they don't bother writing, because that always just equals 1. So you do get that symmetrical pattern. Okay, so let's tidy all of those up. So my constant term is just 3 to the power of 4. So that's just straight into my calculator. So that's 81. Everything's positive, so don't need to worry about signs. Okay, so my x term is going to be 4, choose 1. So that's just 4 times 3 cubed times 2. So that gives me 216x. My x squared term is going to be 4, choose 2. Just wrong thing. 4, choose 2 times 3 squared. Sorry, and then just be really careful that you do have those brackets there, because that 2 is getting squared as well. So it's 4, choose 2 times 3 squared times 2 squared. Oh, sorry, I typed something wrong in there. 2 plus 9. So I'm getting that as another 216. And then I've got, so now I'm looking down at my cubed term. So I have got 4, choose 3. That's just going to be 4 times 3 to the power of 1. So that is just 3 times 2 cubed. So I get that as 96. And then my last term, so the power of 4 term. So 4, choose 4, which is 1. 3 to the power of 0 is 1. So it's just 2 to the power of 4. Okay, and I'm going to check that just in case I can't talk and type at the same time. So 81, 216, 216, 96, 16. Cool. Okay. Right, so then B, hence or otherwise. So because they've said or otherwise, you could just answer B from scratch. It's way more long-winded than it should be. And obviously, if you just go back to the very start and expand those brackets, well, you're only getting 2 marks, and you can see from part A that that's 4 marks worth of work. So let's try and go for the hence method. So basically, what would happen to this expansion if it was a minus 2x instead of a 2x? Because that's all they've changed. Now, it won't just be a case of whacking a minus in front of everything, because let's try and use a new highlighter. Okay, that one. Right. So what would happen if we switched those 2x's to minus 2x? So each of those was a minus 2x. Well, this one would make that term negative. So we would have, so obviously it won't affect the 81. It will make the x term negative. This term, so your x squared term, will stay positive, because if you square minus 2x, it does become positive 4x squared. So that term actually wouldn't change. The cubed term will become negative because if you cube minus 2, it is a negative. But obviously the actual value won't change, and the power of 4 will be a positive. Okay, so obviously that's a heck of a lot easier and a heck of a lot quicker than doing the full expansion again. Okay, and then part C, hence by choosing a suitable value for x, show that 3 plus 2 root 2 to all to the power of 4. Okay, so you want to look, and again, it's that hence word, so clearly these are connected. So if we look, yeah, we've got the 3, we've got the power of 4, we've got the coefficient of 2, so the suitable value of x is going to be that x is root 2. Yeah, that's all they've done. If you compare those brackets to those brackets, they've just substituted root 2 in for x, and then same with those negative ones. And then if we add them, well, let's have a think. Let's go back to our expansions for each of those and think about, well, what is going to happen if we add them? Well, I will have, oh, go away. I will have 81, it's up a little bit. So when I look at the constants, I will have 81 plus 81. But when I look at the x terms, I've got plus 216x minus 216x, so they're cancelling. I do have an x squared term, because I've got 216x squared plus 216x squared. The x cubed terms are going to cancel, because I've got minus 96x cubed and plus 96x cubed. And I will have 16x to the 4 plus 16x to the 4. So if I then substitute x equals root 2 into that, it's definitely worth showing you're working, that this is what you're doing. Okay, so that is going to be an integer. We can tell straight away because that's going to square and become 2. That would then become 4. Okay, but there's nothing to stop you putting that into your calculator, to be fair. Come back again. Okay, so that's going to be 162 plus 432 times 2 plus 32 times 4, which I get as 1154, but I will double check that. 1154, and yeah, we were okay on B. Cool.